Hello, so I have something very cool to show you in this video. I've been playing around with this a lot since yesterday when it arrived, and I'm sort of loving it to bits already. So this is a Radiacode. So it's the same company that makes this, that makes the Radioscan Geiger counters, but this isn't a Geiger counter, although it's ticking away and you might think, oh, it sounds a bit like a Geiger counter. What this is a combination of a scintillator and a spectrometer. So I'll explain what both of those things are for those of you that don't really know, other than, you know, radiation detectors other than Geiger counters. So a scintillation counter is a bit like a Geiger counter, but it's much more sensitive, but they generally end up being much bulkier. But thanks to modern technology, that stuff is now getting smaller and smaller. So if you look at old-fashioned scintillators, they look kind of like you've got a big wand type thing. If you've seen the videos I've done on my Soviet scintillator, which isn't even as sensitive as a Geiger counter now, just due to its age and parts failing. My big old Soviet scintillator, the probe on it is probably like, it's like a baton-sized thing, you know, it looks like a big dildo. Whereas this is tiny, as you can see, because it's smaller than my smartphone. So this is actually smaller than most Geiger counters. So scintillation counters are more sensitive than Geiger counters, which means you can pick up ionising radiation from further away, which is brilliant, you know, if you don't want to actually walk into a field of radiation before it starts picking it up. And it also means that you can hunt down radioactive things a bit easier, especially if you use it in combination with a Geiger counter. This to find out where something is from further away, and then the Geiger counters to sort of look for it, you know, when you know roughly where it is, sort of thing. So that's that. But what a spectrometer does, and this is the interesting bit, and I've got the spectrum on the screen here, is let's zoom that in. What you can see there, and I'll get that up in better quality on my mobile phone in a moment, is a gamma spectrum. So hopefully the camcorder will focus. It doesn't seem like it wants to. That's a bit annoying, but anyway, so what this is, yeah, the manual focus isn't going to work on that. So what that is a gamma spectrum, there you go, is basically where you have X-rays and gamma rays, ionising radiation, not alpha or beta, but gamma and X-rays. They're basically on a spectrum of light. So how visible light, for example, is something like 405 nanometers to something like 680 nanometers, is it? X-rays and gamma rays are the very, very short wavelength radiation. But obviously not all gamma rays or X-rays are equal, because basically, if you visualise that, the further along you go to the right, the more dangerous it is. So one count of something to the right is basically equal to more counts from something to the left. Does that make sense? So that's the reason things like cobalt-60 and cesium-137 are really scary, because their spikes are in the million electron volt range, whereas X-rays are normally about 60 kilo electron volts. So, you know, that's a massively different thing of energy. So I can get the spectrum up on here on my phone, which will make it a bit easier to see. There you go. There is the spectrum on my phone, if I zoom out. So what we can do now is, let's reset the spectrum. So if I click here, hopefully this is all still in frame, I can press here using their app, and I can... Why is that not doing the thing at the moment? Normally you can do restart accumulation. Let me just close the app and reopen it just a second. It's the first time I've had it not do what I'm expecting it to do, obviously, just because I'm doing a video on it. Right, there we go. It's initialised to the device. There we go. I'm just going to turn the alarm off. Now, because these are much more sensitive than Geiger counters, let's just turn all the sound off. You can do that through the app, which is actually quite easy. There we go. So that's the nice thing with the app as well. You can control both of them. You know, if you change a setting on there, it changes it on the app. If you change a setting on the app, it changes it on there. So, you know, you don't have to kind of double do bits, which is good. So anyway, let's go back to the spectrum. So there we go. Here's our spectrum. So if we go there we go. We can do restart accumulation. Yes. So what it's going to do now is start recounting all of the radiation. So the background radiation is going to come in first, and this is, if you look at any sort of gamma spectrogram, you always see these sort of familiar peaks on the left, because that's just background radiation. But what we're interested in is the stuff that's going to turn up a bit to the right of that. Now, because this is very sensitive, and I have lots of radioactive samples, bear in mind, this isn't the best place to demonstrate it, because if I put, obviously, it right next to a sample, you'll get more spikes from those samples, but because this thing is just so incredibly sensitive, it can pick stuff up where a Geiger counter in the same room couldn't pick it up. So for example, where I have my radioactive check sources locked in a safe with lead shielding in it, my Geiger counters, you literally have to be stood right next to it for a Geiger counter to even notice, you know, it's slightly above background radiation. In this room it wouldn't do that. This can tell you that the radiation's in that safe right from here, which is insane. But that's also really cool because you could actually, I think stuff like this would be really good for police use. Say, for example, if they wanted to, you know, have a van with somebody, or, you know, just a regular officer holding one of these, you know, and you know, like walking around the car with it, if they were, you know, at some sort of thing and they were checking in case they were worried that there might be something dodgy inside the vehicle. That's a good use for it. So what you can see anyway happening is the spectrum is, you know, as it detects things, it's adding them to the spectrum. And what this app lets you do on here is, I need to get this in frame, but see, so I can go to this bit, so I go to one of the spikes, and it's telling me that this particular thing is AC228, which is in the chain of Thorium-232. And yes, I have got thorium in the house, so it has picked up some of the thorium. Saying that though, I was in somebody else's house earlier and I had this on, and it picked up the natural uranium and thorium they just had in like the stonework of their house. That's how sensitive it is, but that's also quite interesting. There's a lot of functions on here as well. There's a map feature that's really good, but unfortunately I can't really show you that at the moment because it'd be a bit like, you know, just doxing wherever I've been today. But the map function is good. It's like the atom tags map function. What I'll do at some point is I'll demonstrate that when I'm out and about, do a short video on it, you know, just in the middle of a field somewhere. So anyway, that's that. So you can see the spikes, and I said the app, I think really cool thing with this, let me just zoom it out a bit more so it's a bit easier to see, is, for example, I can, you know, go over one of these spikes, and if it's a known radionuclide, see that's something from radium-226's decay chain, that one where there's a bit of a spike forming. You know, you can go over all of these, and it'll tell you what it's from. So, there isn't any cobalt-60 in the house, but obviously you'll get some spikes that are just from various things crossing over. The longer you leave this running, the more accurate it will get as well. And obviously I've got the amplification on, so if I put that down, you can see that actually most of the stuff at the moment is, you know, a lot lower than it looks on there. It's just little spikes. So the really cool thing with this is obviously, if you're out and about with this and it started picking something up, you can check using the phone and you wouldn't have to know yourself the gamma spectrum, you know, or look up images like you used to have to do if you used a spectrometer. You know, you'd see your spikes and you'd have to look up essentially an index of radionuclides to find ones. These are all programmed into the app for this, which is really nice. So obviously you can just go over where you see a spike and it will say, oh look, that's Thorium-232. Well, you can't see that because there you go. But yeah, so that's really cool, because obviously it means if you find a random radioactive sample, it will tell you what it is. And there's also a very good thing to do with dose regarding this. So let's go to the main screen. So looking at this, another advantage of having a spectrometer is it will give you a realistic dose with everything. Now, as I've said before, a Geiger counter is calibrated on one type of radioisotope, they're normally cesium-137. So what that means with a Geiger counter is, for example, if for example, say you're exposed to something that's less dangerous than that, you get an artificially high reading. There's not many things more scary than cesium-137, like cobalt-60 maybe. But, you know, the point is that a Geiger counter is only going to give you very accurate readings if it's measuring the right radionuclide for what it was calibrated on. So if you're looking at something like Fiesta Bowl with a Geiger counter, it seems scarier than it actually is. And I can demonstrate that with this, because it's going to tell us that although we're going to get a reading from Fiesta Bowl, it's not actually, you know, the scariest thing in the world. So there's that. So that's cool. So yes, this gives you a more realistic dose than what a Geiger counter gives you, because it can actually see where the energy is coming from. But bear in mind, this won't pick up alpha and beta as far as I'm aware. It's just X-rays and gamma rays. Although beta will give Bremsstrahlung, however it's pronounced, breaking radiation, basically X-rays caused by beta electrons hitting something, will register on this. So you can detect beta kind of like second-hand beta, if that makes sense through this. So anyway, I'll show you the functions on the actual dosimeter itself now rather than the app, because as I said, the app gives you a lot more detail, but you may not be using it with a smartphone, and everything with this will work without using a smartphone. Okay, so hopefully this won't be too bright for the camera. So we're on the spectrum mode at the moment, so if we hold this button down, we can go to the menu. So we've got settings, I'll go through all those in a moment. Spectrum, that's the one you could see there. Monitor, that's where it's just showing you active radiation levels. So that's basically like what you'd have on most Geiger counter type things. 26 Celsius, that's the temperature. Okay, dose, so this is current dose and counting. So it's 877 microrontgens. So microrontgens, basically 1,000 microrontgens is a millirontgen. So this is about almost 0.9 millirontgen now. Okay, so that's that one. Search, this is a bit like using a search mode on a Geiger counter. If you're trying to find where a radioactive source is, obviously this is what you'd use, because you'd walk around, and as the CPM gets bigger, or CPS, whichever mode you're using, you can then you know, use that to zero in on where the radioactive source might be. That's power off, that's pretty straightforward. Right, settings, so display units, you can have it in CPM or a radiation like dose thing. So measurement units, that's where you can change it between rontgens and sieverts. So I'm going to keep it on rontgens, and I want count rate in CPM rather than CPS, but that's the two options there. So dose rate, you can set alarms for when the alarm goes off based on, you know, if your current dose per hour or whatever goes over that. So they're quite low at the moment, but that's fine. You can have a dose, alarm 1, and alarm 2, so as in when you get to 100 rontgens it would set those, and you can change those. Screen, that's just for the backlight and the auto rotate, pretty straightforward. Signals, so this is where you can have sound. So if sound is on, obviously it's ticking, sound off it's not. Vibration, you won't be able to tell this from a video, but it vibrates when you press a button on it and stuff like that, and it's also for the alarm function. So if you've got it in a pocket, it will vibrate as well as doing the alarm. Light, that's pretty straightforward, the light is for the backlight. I think that's also so it lights up sometimes when it detects radiation. Or is it that light? Oh yes, sorry, it's the flashing LED, not the backlight. Clicks, so when you've got sound on, that's it ticking. Buttons, that's just when it makes a noise when you press a button. Alarms, again, you can have the alarms off if you want as well. So if you're going to be using it to measure samples, you probably don't want the alarms going off constantly. So if you're using this as a personal dosimeter, you want the alarms on basically. If you're using it to measure basically gamma spectrums, you probably won't want that on, because every time you put it near a sample, the alarm will go off unless you set it really high. But there you go, and that's those. So there's the settings. So as you can see in the Bluetooth, pretty standard language, you can either have it in Russian or English. And obviously I don't speak Russian, but the English is absolutely fine on here. Time, that's the current time, that's pretty obvious. Device info, just shows you about the firmware and everything on there. Right, okay, so what I imagine you want to see now is it actually working as a spectrometer. So I'm going to try and demonstrate that using a couple of different things, and we'll see if it comes up with the correct spectrums for what I know the sample is. So first, shall we get out my bit of cesium-137? I think that will be interesting. Okay, so as you can see there, here is a proper sample of cesium-137. You'll know what this is, obviously, if you're into spectrum sort of parts. I bought this from America where I could do it legally, but that was a very expensive way of getting it. But if you're in America and you can buy the complete set of sort of all the isotopes in very small amounts, they're very sort of interesting with spectrometers. So anyway, let's get this and put it on top of there. The detector bit's about there, where it's got the sort of ionizing radiation symbol. And what I'm going to do now, while it's sort of looking at that, is I'm going to reset the spectrum again, because what I want to do is, so if you can see on the log stuff there that it's obviously telling me on the phone as well, there's a thing there. Right, we'll turn the alarm off, and what we're going to do with the spectrum, we'll just zoom that out a bit, is we're just going to reset that now, so we know anything it's picking up is from the sample. So restart accumulation, yes, right, there we go. Right, now let's see what happens. Because what we should start seeing soon is that the spikes that are more typical for cesium-137 should become more evident, because it's sitting right on a sample of cesium-137. So the interesting thing as well is if we go into different mode, because it's in search at the moment, in dose, obviously it's saying that, oh sorry, that's a cumulative dose, isn't it, that one, we don't want that. Monitor. So as you can see, it's saying from this little sample we're getting about nearly 300 microrontgens, and this is pretty damn accurate for stuff like this, because again, this will know it will be cesium-137 based on the spikes. So this is, funnily enough, this is the only sample I've actually got where if I use it with the majority of my Geiger counters, they'll give you the exact correct reading on it, because it's actually cesium-137 and a proper, like, you know, pure lab sample of it. as opposed to, you know, it being something like, oh, I've got this alloy and I don't know what's in it with radioactive materials, or, you know, I'm using a Geiger counter on Fiesta ware and then it's going crazy sort of thing. So anyway, let's see, so what spike is that one there? Cesium-137, look, there we go. So there's that big spike there, and Cesium-137. So there we go, it's correctly identified as Cesium-137. Again, the longer you run it, the more accurate it will be. Again, we can amplify the smaller things if we want to. So if we have the amplifier on, you'll see that the Cesium-137 spike is the biggest one, because that's the thing that's not really background. And yet, Cesium-137, so it's correctly identifying that spike as Cesium-137. Very easy to do using this, and that's why I find it really interesting, this, because obviously, if you're interested in what the nuclides are. So what we can also do is set this now to the spectrum mode on here, and you can actually see on the little screen there, look, that you can also have this in logarithmic and linear mode on here. Right, if we zoom out and hopefully it focuses. Maybe. Let me move my screen away so that's not the brightness there. Yeah, so see that as the log mode, you can see the spike there where the Cesium-137 is on the spectrum. Which, it's one of these buttons I think that changes it from, she might have to unlock it. Yeah, there you go, and there you can see the linear spike from Cesium-137 as well. So there's that doing what it does. So it's correctly identified Cesium-137, so test 1, it is accomplished. Good. So I'm going to reset the spectrum in a minute and get another radioisotope. So, a thorium lamp mantle, so let's stick this on here, and I'll turn the alarm back off. Right, so that's the alarm turned off. Let me reset the spectrum. So restart accumulation, yes, so we don't get that Cesium-137 spiking there. And you might notice already that we've got a very different pattern emerging. Let me turn the amplification off for now, then we can put that back on in a minute. So what you can see of the thorium is you've got lots more of the sort of broader range of spikes coming on. So obviously with the previous one you had your background radiation and then you had essentially the big spike for Cesium-137. What you'll see with thorium is that you get lots of sort of little bits all across the energy spectrum. So let's have a look. So actually I might put the amplification on just so we can see the spikes a bit easier for the... I'll put the filter on as well. Filter just basically, if you can see that, what the filter does is... I can get that selected. The filter's just if you want the spikes sort of as very small little direct spikes, or if you just want it sort of smoothed out. I personally prefer it smoothed out for clicking on, but it's up to you. So there you go, that's the difference that makes. Right, so let's see some of the stuff that's coming on there. So yeah, we've got one of the spikes there, chain TH. Let me zoom that out so you can see it. Zoomed out too much. So you can see one of the spikes we've got there is Thorium-232, correct. Is that a spike there that looks quite noticeable? I'm just seeing if there's any other... it looks like this might have a bit of radium contamination on this as well. You will find with natural uranium and thorium that you often run into radium as well through these, because obviously, even assuming that you didn't have any sort of radium sample leak on it at all, it does seem that I found from playing about with this with natural ores type things that obviously, because radium is naturally occurring and thorium and uranium-238 are naturally occurring, for example, it seems that sometimes you don't get a pure sample of something. But yeah, as you can see with this, yeah, there's another one of the thorium spikes on there. So it's definitely identifying that this is thorium based, and it seems like it's getting a bit of radium on there. But I don't know if that's just because it's been near another radium sample of mine and, you know, a bit of radon's got on it and then other bits of the radon, you know, radium decay chain are on there confusing it. That's entirely possible. Or it could be that, you know, this wasn't pure thorium when they made this particular mantle. So what we're going to do now is get, shall we, an old radium compass, something like that, where we know it's radium, but radium-226, but will this know it's radium-226? Let's find out. So what we've got here is an old radium compass. That's not a British Army one, I think this might be a Soviet radium compass, that one. Anyway, let's reset the graph again. So, restart, yes. Right, there we go, so that's the graph restarted. If I just put that over there so you can see that. At the moment, you know, you're mostly just seeing the background radiation there. Now let's put this on top of the compass. There you go. It doesn't look like this one's too strong in terms of radium paint, because obviously it's noticing that it's active, but it's not sort of going crazy on this one. Anyway, so now let's look back to that and see what spikes we're getting. So we are getting... Oh, I've zoomed that in way too much. Hang on. Right, there we go. So we've got a spike there, radium-226. It's not even all in frame, is it? I keep doing this. So let's get that down there. So as you can see, big spike there. Let's click on that one. I thought I had that come up with a number then. Yeah, there we go. So there's that one. Radium-226 decay chain, correctly identified. That's uranium-238, which is probably going to be in there as well if there's radium. Let's turn the amplification off again for a moment to see what bigger spikes. By the way, I think when it has a spike at the very far end, I think that's telling you when its energy that it can notice is there, but you know, it's outside of its spectrum, if that makes sense for the spectrometer. I think that's what it is. It's basically telling you, I know there's ionizing radiation there, but my sensors can't detect exactly what it is. I think that's what that's telling you. So anyway, we've got 2 spikes there. But yeah, we've definitely got a radium-226 spike there, it's correctly identifying. There's K40, whatever that is, saying that's a spike for that. There's Bi-214 from the radium decay chain there, from that spike. Again, it's getting bits of thorium and stuff like that on there again. I don't know if that's just because it's picking up other radioisotopes through the wall. But yeah, from what this is, it's definitely picking up bits of radium-226. I imagine on the stronger radium-226 sample, it might, you know, give a better thing of that. Let me get the, what's it called? That scary Geiger counter. The DP63. Let me get that and we'll see how crazy that goes for the radium on it. So there we go, there's a DP63A, and funnily enough this is setting this thing off from quite a distance. But let's put it on the actual bit where the radium is going to be the highest. There. This one's still sealed up in the meter. Oh, assuming the vibration doesn't knock that off. So anyway, let's turn the camera around. Oh, the vibration's knocked it off, hang on. There might be some X-rays from here, because I think the strontium-90 is inside this one, so there might be some breaking radiation from that. Anyway, that's that there. Now let's reset this one, so we get things just from this meter that's here, for the most part. And we'll turn the amplification on actually again. Is that zoomed in a lot, or is that... No, that's fine. Right, so let's see what it's finding. So, you've got a spike there, there's thorium again. I mean, as I said, the longer you leave this running, the more accurate it's going to get, because you're going to, there's a radium-226 spike it sees there. I mean, this thing's giving it nearly the entire spectrum, isn't it? Have a look at that, that's crazy. Yeah, it seems to know there's at least some radium here, because it's getting a couple of the bits with the radium bits on it. But as I said, I think you're getting both breaking radiation from this, from the strontium-90 inside hitting the sort of, you know, bits of the Geiger counter, plus whatever you'd get in radium paint, so probably a bit of uranium and thorium as well. But we've got another big spike developing there. What's that one? A thorium spike again, interesting. See, unless, again, it's just picking up stuff, because I said the problem with this is, because of how sensitive this is, I'd need to kind of not even do it in the house. Because the problem is as well, is if you literally take this into somebody's house, this will actually detect a smoke alarm with americium in it from across the house. It's that sensitive, which amazes me. Like, don't get me wrong, that's really, really good. But at the same time, I suppose it makes it a bit more difficult if you're trying to narrowly work out what something is. But yeah, anyway, so there you go. That's what the spectrum's looking like from a DP63. Pretty crazy, isn't it? All of that ionizing radiation coming off of this Geiger counter, you know, something that was meant to detect radiation. Now, let's do something interesting. What I want to do now is get the DP2 control source, so a big bit of strontium-90, put a metal plate over it, and then we'll see what sort of energy X-rays come from the breaking radiation. Okay, so here's our Eye of Sauron, and what we're going to do, so DP2 control source, and mine's actually a relatively weak one. Restart accumulation. Right, first I want to see what happens if we put the detector directly over the thing. That actually registers that fine, so that's interesting because obviously the actual level of radiation is much higher than what it's detecting on there, but I imagine that's just the breaking radiation from the electrons hitting the plastic case, which is crazy if you think about it, that it's that good at picking up you know, the secondary radiation from beta rather than it being the actual beta radiation. So anyway, the phone there shows mostly a spike around here, which again isn't actually saying a radionuclide kind of thing, it's just saying it's, you know, nearly, so it's saying it's nearly 2 MeV, that spike. But yeah, that would, I assume, a thing like that actually be breaking radiation. That might have been what we were seeing a bit with the other thing, that breaking radiation just kind of has a spike of energy and that then just goes downhill, essentially. So if you had a Americinium-241, that would be there, apparently, on the thing. And then, yeah, that would just go downhill. So let's now get this, put this under this bit of metal here, which you can't see, under a little tin lid, and then put this back over the top and see what happens. So yeah, now I'm going to set the graph again. We'll turn the alarm off. And let's see what sort of, what our graph looks like. So see, now that's interesting, we're getting different spikes on there because of the different medium the electrons are hitting, which is actually pretty fascinating. So we've got a bit of a spike there, which again would be radium-226. It's always possible there's a bit of radium contamination on there. But yeah, I think more what this is just the fact that obviously you get breaking radiation at different sort of frequencies based on what material it's hitting. Because if I remember right, if you store strontium-90 behind lead, you get stronger X-rays than if it was stored behind like a thick bit of plastic, like plastic's safer. Because this is the reason I store this in glass. So anyway, if you want to see the dose type thing, at the moment this is saying, I can get that to flip over, there we go. It's saying you're getting about 15 millirontgen per hour, 10 millirontgen per hour from the X-rays this is generating, 25, 29, 30. Anyway, so you can see it also on that screen that different spikes are forming as well, depending on, I guess, how the X-rays come out. What we're going to do now is put this DP2 control source back how I actually store it, which is inside one glass jar, inside a much bigger glass jar, because that massively cuts down the radiation dose. So now, let's stick that on top there, and it still can obviously detect the breaking radiation coming off of there. Let's restart this again and see what accumulation differences we get. So notice again the spectrum's looking a bit different again this time based on what the electrons are hitting. So it's good to know this will actually pick up beta radiation fairly well, but just display it as X-rays or gamma rays. Well, I suppose it can only be an X-ray, can't it, if it comes from beta hitting something because of breaking radiation. That's interesting, the fact that, you know, this will reliably pick up beta in the sense of just it rebounding off things as X-rays. So again, it's saying it could be radium, it's saying it could be uranium-238. So yeah, obviously, I think this one is obviously, if you're using something that you know is producing X-rays, don't look at this and think, oh, that's definitely you know, going to be one of these radioisotopes. But it is interesting in the sense you can see what different frequencies it picks up. So what you could do with this, I guess, as well, and I have to test this, I won't do this today, but with that Chinese X-ray camera thing I've got, I'll have to see what it reckons the frequency ranges of the X-rays coming off that, because I'd be interested in knowing, like, how many of them are just awful, like, you know, low energy X-rays that just would burn your skin but not actually provide good medical imaging quality, and how many of them, you know, like 60 keV or whatever else. Anyway, so again, that's interesting because you can see a different sort of thing assuming. It's interesting on this one that there's not much in that area. You know, you've got, oh, there's one popping in there now, I see that. But yeah, so again, that's interesting that, you know, it is picking up through the glass, the X-rays coming off of that. However, the interesting thing is, if I had a Geiger counter handy, which I don't because my radio scan's in the other room, with that in there, the Geiger counter would barely get a reading, which is the funny thing. But obviously, if I had it out, the Geiger counter gets a much higher reading than this does, because it's directly reading the beta radiation. So that's an interesting thing. So this is obviously why, if you wanted to be detecting alpha and beta, you would still want a Geiger counter. But this is obviously for different purposes. So it's a nice thing to have alongside a Geiger counter. But yeah, there you go. See the spectrums forming on there again. Right, let's pick one last thing to test with it, and then that'll be the end of the video. But as you can see, I'm very impressed with this thing. So here we have a good old-fashioned Fiesta Bowl, back when people thought painting stuff you'd eat off of with uranium paint because it made it look pretty was a good idea. So let's pop it in there. And that's chirping away. Now I'll reset the graph and I'll turn the alarm off because you know, we don't want to keep hearing that vibrate. And let's have a look at what this senses on here. So let me just turn this round as well, so it's trying to get it to flip the screen. There we go. Now, again, I think when we get to see this graph, it's going to be a mix of uranium-238 and thorium, and maybe even some radium, because again, radium is probably going to turn up down uranium's decay chain, and thorium, again, similar sort of thing, where often they're found in the same sort of places. So unless it's a completely chemically pure refined uranium-238 paint glaze, which I doubt it is, you're probably going to get other things mixed in there with it as well. Like I said, if you take this down to a quarry, for example, you're going to find all sorts of naturally occurring, you know, radioactive things there, because, you know, it's not like the ground is segregated if you walk somewhere, like only uranium is in one bit, only thorium is in another. Often you quite have a mix of various things. Right, okay, so let's see what we're getting. So we're getting radium-226 there, which makes sense. That spike, it doesn't identify as anything. Bit of a spike there, thorium-232, again, as we said, that's kind of to be expected. Bit of a spike there, that's cobalt-60, definitely going to have like cobalt-60 in there, so that's just a bit of energy in the same sort of wavelength, but not thing. Uranium-238, that makes sense. Radium-226 and thorium again. And also bear in mind, it could be beta radiation, because it's giving off a bit of beta as well. Any beta radiation hitting the plastic, or even hitting other bits of the bowl, could then be turning into weak X-rays, which are then, you know, going to show up on that scale as well. But yeah, so as you can see, it does that. So yeah, I'm very, very impressed with this. Now, I'm not sure what the RRP is going to be of these yet, because I don't believe they're for sale in the UK. As I said, Radioscan sent me one, because obviously I do videos on radioactive type stuff. When I looked on a Russian website, assuming that this was all legit and they were brand new and, you know, not second-hand ones, and, you know, assuming that the prices are all stable, I think it was about 11,500 rubles for one of these. So I believe that's somewhere like around $150 or £150, maybe between $150 to $200 or pounds, I think. So assuming that they're sold for the same price over here, and that's a legit thing, that's an amazingly good price. But as I said, at the moment, I can't say, look on, you know, the Radioscan website where you can buy the Radioscan 701A and, you know, 801A, because they're not, the radio codes I don't think are listed on there yet when I had a look the other day. But, as I said, these are a really, really cool thing, mostly just because of how sensitive they are. What I'll do, actually, before I end the video, is I'll get a Geiger counter out, and I'll get the Radioscan 701A out. I'll put the back cover on so it only lets hard beta and gamma through, and I'll demonstrate how much further away this will pick up ionising radiation coming off of the Fiesta Bowl, for example, than actually, let's use a bit of americium-241, because that's even harder for a Geiger counter to detect the gamma from, just to demonstrate, because you'll find this interesting. Right, there's a coin of AM-241, so we'll zoom out, go all the way over here, and there you can see the Radioscan 701A, and this one, the Radiacode. So, watch this. So if we get the, let's just get this in frame. So if we put this over here, that's still at background levels. If I put it right on top, look, you can notice it's making it tick a little bit faster. And again, that's not to be surprising, because even a quite sensitive Geiger counter, if you're in gamma only, you know, you've got a shield on it so only sort of gamma energy can get through, it's going to struggle a lot more to pick up AM241. So obviously it knows it's there with the gamma only mode. What I'll just do actually is put it in the beta mode using this plate, just in case, you know, some of the softer... There we go, so you can see that's a bit higher there. Yeah, there we go, that's a better example. So, because obviously if you've got a beta window, that's got an alpha window on there as well. With the alpha window open, it would be giving a much higher reading. But, so yeah, with this, you have to get fairly close before it picks it up reliably. That's not a problem with the Geiger counter, it's just the way Geiger counters work. Now get this over here. Notice how easily that's going off. So from that sort of distance, that can reliably pick up the see, if you see it says 025 on there now, it's probably quite hard to see the screen. But if you look at the sort of readings you're getting, let's put that back over there. That's actually not gone quite down yet from where I've had that one on there. But the point is, if you actually notice, the point of this is that obviously this picks up gamma sources from much further away. As I said, the other day I went to my granddad's house. Every single room in the house, it would pick up his upstairs smoke alarm. Because that's obviously a Americinium-241 one. And yeah, so that's what was crazy, that, you know, I was looking around the house thinking, oh, has he got an old radium clock somewhere or other, and it was the smoke alarm in his upstairs hall. So, you know, it was picking the gamma rays up from the smoke alarm through, you know, several walls and floors, which is kind of amazing, whereas obviously a Geiger counter could not do that, because as I said, with a Geiger counter, you literally have to get it sort of that close to it to get a reading. Whereas with this thing, notice how much faster it is as well. Probably going to be a bad angle to see the screen now, but... And if we go again to the spectrum screen, I'll just show you on here. And we'll do logarithmic because it's easier to see. You can see again where there's different bits on there, and I have tested it yesterday with AM241, and it definitely showed the spikes in the right places for AM241. But yeah, there you go. So that's that. So compared to a Geiger counter, it's actually smaller, which is crazy, because I did not expect that before I got this, that it'd be smaller than the Geiger counter. But there you go. So this is the sort of one you want if you just want to detect all sorts of radiation. And I said, the nice thing of this is you can pick up alpha as well. So obviously if you put that there like that, that really will pick it up, because it's picking up the alpha through the alpha window coming off the Americinium. So it starts even picking that up through that Geiger counter, look. But yeah, so anyway, depending on what you want one or the other, or get both. But if these are RRPing at the sort of prices that that web page in Russia seems to indicate, this would actually be very, very good value for money, because I don't think there's much on the market like this at all. Atom Tag might do something like this, because I've got the Atom Tag little Geiger counter that Kraken sent me, but I think they do an Atom Tag scintillation counter as well. But the fact that, you know, you can use this and it's got its own little screen on it, you're not required to use it with a phone, but you get more features if you do that. That's really, really good. Also, yeah, you can detect radiation through walls a bit more easily, so let me just show you that before I end the video. So that's the room through there where the safe is with the radioactive materials in. So if I put that there, If that's in frame, notice that's not going up at all. Then if I get this one, put that there, where you can actually see it, you might notice that that's actually ticking faster. That's literally picking the radiation up through the wall, despite the fact a Geiger counter can't even notice it. That's crazy. But there you go. So as I said, they're different tools for different jobs, but the Radiacode I am very impressed with for what it is. As I said, it's got a mapping feature as well. You know, there's also a log mode on it. I'll just quickly show you that I don't think I remember to show you in the video. So if we go on to log mode, what that basically does is it just constantly shows you how much the radiation's increased sort of every minute sort of thing. You know, what your total dose is, so you can look at all of that on your phone. Probably not going to want to focus, is it? But yeah, I'm just saying that's interesting. So you can see as well that when there's been like higher doses, they go red on there, things like that. Yeah, there you go. So as I said, this is a very, very interesting thing. Thank you a lot for Radiacode sending it me, or Radioscan, or I suppose the company's actual name is just Scan Electronics. That makes sense. Yeah, so Scan Electronics, so thank you to Scan Electronics for sending me this. It's really, really good, and I think a lot of people who are into radiation detectors will really want one of these when they actually become available in whatever countries, you know, they're selling them in. Because obviously, we all know the Radioscan 7018 is a very good Geiger counter, so this is a very good kind of different sort of counter.